Hello, algebra students. Today we're going to be working with factoring trinomials. So in essence, you're going to be going backwards from what you've been doing thus far. You've been given a binomial and multiplied it by another binomial, or you may have been given a binomial and multiplied it by a trinomial, but you've been basically distributing, multiplying, combining those terms, and now we're going to go back the other way. When you see factoring trinomials of the type x squared plus bx plus c, what that tells us is that the term in front of the x, the coefficient in front of the x, is always going to be a 1. And so that's going to make what we're doing today a little bit easier than the direction that we're headed. I can factor a quadratic expression to rewrite it into its factors. So the name of the game today is always going to be to break into two binomials. Here are some steps that you can always refer back to if you are struggling. Steps to factor trinomials of the type x squared plus bx plus c. The first thing you're going to do is find the first term in each binomial. And so in order to do that, you have to look at the ax squared term, or the x squared term, excuse me. You're going to look at x squared, and then that's going to help you to decide what is going to go into the parentheses. So in the case where it's x squared, it would always just be x times x. Number 2, think of factors of the third term that would create the middle term. So I'm going to help you with this. We're going to just list all the factors, and then we'll determine the sign. And also at the same time, we're going to be thinking about the middle term. I hope you enjoy this. I like it. It's kind of like a puzzle. Note, I think it's just kind of it's good to know the direction that you're headed. And so terms can be either both positive, or they can both be negative, or one can be positive while the other's negative. So in other words, you could have something like x plus on both. You could have x plus and minus on both, or you could have then two negatives. So that's what I just wanted you to know, that all of those are possibilities. All three of those are possibilities as you're working on the examples today. Factor each expression. So the first thing I want you to ask yourself when you're looking at a trinomial is there a factor that I can pull out of the ax squared term, out of the bx term, and of the c term? In other words, is there a number that I could pull out and then write a different trinomial, multiply it by that in order to simplify? And the answer is no, but I want you to get in the habit of that, because when the answer is yes, it's going to make your life a lot easier, because you've just kind of forced yourself into that. So today you're going to be kind of annoyed with me because I'm going to remind you each question to try to pull out a term or terms if you can. And the answer will probably be no, but no, I know it will be no. But anyhow, we're going to remind ourselves of that because, like I said, I know the direction that you're headed. So there isn't a term I can pull out, so then I'm going to just do my two binomials. And here's the thought. Remember, step number 1, you can look back at your notes. Step 1 says find the first term in each binomial. So I know that the variable I'm using is g. So that's going to just be g times g. Easiest thing you've done all day, right? Then you're going to look at your third term. Notice number 2 says think of factors of the third term that would create the middle term. Okay, what does that mean? Well, I want to think of numbers that I can multiply together to get 10. So I would say 1 and 10, that would be a set. Or I could use 2 and 5. There are no other pairs of factors that go into 10. At the same time, I'm thinking about which one it's going to be for the c term. When I multiply together, I have to think about what can I combine in terms of terms to get the middle term. Well, we know that 1 and 10 is not going to get us there, but 2 and 5, I notice that's pretty interesting, because I know that 2 plus 5 will give me my b term. So I have to determine what kind of signs am I using. Well, I notice you have to kind of think about it at the same time, because we're looking at this sign because we know that it has to be either a positive and a positive or a negative and a negative. But at the same time we're thinking about that, we're thinking about the middle term, which is positive. Well, I'm not going to get to a positive if both of these are negative. And so our final answer then would be plus 5 and plus 2. And the order doesn't matter. You could write g plus 2 or g plus 5. Now, this is our first example, so we know that this is our answer, but let's say that we're just not quite confident. You remember FOIL. So we go back, now we have two binomials, and we're going to multiply those together. So if I did first, that would be g, I don't know if you can see that color very well. That would be g, that's still not that much better, g and g. And so g times g, we know, whoops, now I'm writing with a highlighter, is g squared. Good. And then plus our outer term. So our outer terms would be g times 2, or 2g. Our inner terms would be 5 times g, or 5g. And then last is going to be 5 times 2, or a positive 10. So overall, we ended up with g squared plus 7g when I combine the two like terms, and then plus 10. So we did a fantastic job our first time around. Our final answer is g plus 5. I'm just going to rewrite that because I kind of messed over it. G plus 5 times g plus 2. Now let's go to our second example. Our second example is v squared plus 21v plus 20. First thing you want to ask yourself, is there a factor that you can pull out? Nope, there isn't a number that I can pull out of 1, 21, and 20. And so I'm going to go ahead and just use my parentheses to represent two different binomials. The first term is v. That's going to be v times v. And then I have to consider, what do I multiply together to get 20? Well, that's going to be 1 and 20. That's going to be 2 and 10. That is going to be 4 and 5. So I know that it's going to be a set, one of those pairs, one of those three pairs. And I noticed two things. I got to recognize my sign. So I have a positive here and I have a positive here. In order to get to 20, 1 and 20 will do the trick, and 1 and 20 also will do the trick with the 21. Are you guys convinced? If not, let's think about it. 2 and 10, well, that's not going to get me to 21. 4 and 5, again, that's not going to get me to 21. The only way I'm going to get there is by using a positive 1 and a positive 20. And once again, the order doesn't matter. You can flip that around, of course. So if I was foiling this back out, it would be v squared plus v, 20v plus v plus 20. And of course, that works out. So it is important for you to consider the signs as well, all kind of at the same time. Here is our final answer. That was just our check. All right, now we're going to get into some more interesting. Those, what I just showed you are the easiest types of problem, I would say, because they're both positive. And so if the middle term is positive and the outside term, the C term, is positive, you know that your sign and the binomial is just going to be positive. But now I notice that I have a positive and then I also have a negative in the center. So let's think about that. I'm going to look and ask myself, can I pull a factor out of 1, negative 10, and 25? No, I cannot. So if I can't, then I'm going to just go ahead and create my binomial. It's k squared, so I know that's k times k. And then I've got 25. Well, that's going to be easy because 25 doesn't really have a whole lot of factors. It's only 1 and 25, and it's 5 and 5. And at the same time I'm thinking about that, I'm thinking about what I can put together to get a negative 10. Well, is 1 and 25 going to get me to 10? Is 5 and 5 going to get me to 10? Yes. So I can kind of just not necessarily concentrate on the positive versus the negative at first, but just kind of think of those factors and what you can combine together to get that number. In order to get a positive 25, I know that that has to be either a positive and a positive. But wait, Houston, we have a problem because this is negative. So if the 10 or the b term is negative, then I know the only way I'm going to get there is if both signs are negative. So here's the point, that if your c term is positive and your b term is negative, then that's going to require a negative in order for you to get there. This also could be written as k minus 5 squared, and it will fall into special cases. We'll talk about that in another lesson or two. I want you to pause the video for me, and I want you to go ahead and try number 4. Since we've done 3 examples, we do have 3 more to do, but I want you to go ahead and try number 4 on your own. So your final answer there should have been x minus 9 times x minus 2. And so those, so far we did 1 and 2, both were positive. We did 3 and 4, both were negative. once again, if the C term is positive, but the B term is negative, then that's going to make both of those terms negative. Now let's look at our last two. I'll do 5 with you, and then I will ask you to try 6 on your own. So on number 5, ask yourself, is there a number that I can pull out of 1, 3, and 40? No, because if the coefficient is 1, of course, we're not going to be able to simplify that. So I'm just going to go ahead and make my two binomials. I have to consider 40. 40 is kind of a big number, but I still need to think about what I multiply together to get 40. So I've got 1 and 40 for sure, and then 2 and 20. What else? 4 and 10. 5, I'm just thinking in my head, 5 and 8, 6, 7, 9. Nope, now I've got to 10, so now I've completed all of my pairs. So I've got four pairs of factors to get to a negative 40. So here's what I know. P squared, well, that's going to be P and P. You probably already filled that in. It's in order to get to negative 40, I know that 1 has to be positive and 1 has to be negative. So this is going to be, these are the trickiest type because you have to put the number in the right place. When they're both positive or both negative, then that's pretty easy. But when I have to consider one's positive, one's negative, we want to make sure that we're getting to a negative 3. That is our goal. It's like B is the ultimate decision maker. Well, 1 and 40, that's not going to get me there. 2 and 20, no way, Jose. 4 and 10, not so much. Ding, ding, ding. I think we have it here. 5 and 8. But I have to think about what's going to give me a negative 3. In order to get to a negative 3, this is going to have to be an 8 because it's negative 8, and then a positive 5. That will get me to negative 3. Isn't this so much fun? All right, go ahead and pause the video, and I want you to ask yourself the question on number 6 is, can you factor anything out? Well, no, not so much. Not if I have a y and a y, and that's just not going to work out. Because 1 is the coefficient, there's no way I could factor anything out, okay? So go ahead and pause the video and try this one on your own, and then come back once you have finished. All right, hope you're back now. We've got our final answer, which is y plus 7 and y minus 8. So let's think about that. I listed out the factors for you, and I know that I'm trying to get to a negative 1. That is my ultimate goal. In order to get there, then I would need a negative 8 and a positive 7. So be very careful. Like I said, these are the most challenging, is just when you have when you have to use positive and negative. I hope you really enjoyed your lesson today on finding the factors of trinomials in the form ax squared plus bx plus c.